Let's take a look at this assembly, and so I'm going to free move this end block out of the way over here, and then we'll take some measurements. So I'll go to the inspection tab and I'll do measure. I'm going to set my precision much higher just so that we can examine some of these dimensions. And so I'm going to measure the length of that, and I see that that is 30 millimeters. And then I'm going to measure the distance from here to here, and I see that is 30 millimeters. When we manufacture something, we're going to have a plus or minus tolerance associated with every dimension. We can't make something that's exactly 30 millimeters. So some of these, the slots may be a little smaller than 30 millimeters, or it'll be bigger than 30 millimeters. The same way with this one. We can specify a tolerance, say a plus tolerance or a minus tolerance, but in the end, if this is exactly, let's say this was exactly 30 millimeters from there to there, 30 millimeters from there to there, these parts are not going to go together unless you use an arbor press or a big hammer to put them together. So we have to have clearance between parts. We can't have that exactly 30 millimeters on both of these parts. And then if we're going to 3D print this, 3D printing isn't a very precise process, so we may need to add more clearance between the parts than we would even do for precision machining. And if we go around, the rest of this is all the same way, so that's 7 millimeters, this is 7 millimeters. You can't do that. That won't work. You know, all of these, whoops, I need to do this one separately. That one's, you know, that's not going to work. If I get the measure that one's 5 millimeters, this hole is 5 millimeters, none of that is going to work. So the same way down here, you have to have clearance down there, have to have clearance on these shafts up here, have to have clearance between this shaft and this part, or it's not going to slide along there. So we have to have clearances between parts. We're also missing clearance between this dovetail, the slot, and the dovetail. It's not going to work. Have to have clearances. And then even bigger issues, and actually when I go to look at this, I see that the assembly is skewed in the main assemblies. So I'll go here and I'll click on look at, and I'll look, so I look directly at that, and we see some interference between the gears right here and the gear down here. And so when we make gears, we typically purchase those off the shelf from a company that's all they do for decades. They have made gears and they know what they're doing. And so in Inventor or SolidWorks, the gears are made as cosmetic geometry, and then if you want to make true involute curve geometry, then you have some more modeling work to do to get that correct geometry. And then we'll look at this pin going into this slot. Creating a slot like this even more complex than creating the gears. Now in Inventor 2020 there is a new functionality that makes this easy to do, but in the earlier versions of Inventor it was a lot of work to create a slot like this to do it correctly. Now, if we go to analyze interference and I say analyze the interference between that part and this pin, and we'll say OK to that, we see that there is some interference in here and interference over on the other side. Let's change the color of that pin so maybe it'll be easier to see. I'm going to change that pin to some other color. Okay, and then we'll do that, analyze interference again. So I want the interference between this part and this part. And so those red areas are the areas of interference between those parts. This slot was modeled incorrectly.